Hello, welcome back. This is Mr. Long, your math teacher today. Now, in this lesson, we're going to go through quite a number of questions from the Primary 4 Maths examination paper. Now, these questions are all taken from several years of P4 end of year exam papers, and the questions are classified according to the different chapters in your workbook and textbook. So, now for the simpler question, I'll just breeze through. For the harder questions, I'll spend a bit more time explaining it. Without further ado, let's get started. Now, of course, if you are my student and if you're using this for your correction, please make sure you have your corrections written down. And corrections means working, not just the number that you see here on the right hand side. Let's get started. Which of the following numbers does the digit 6 stand for? Now, stand for means what does it represent? Now, digit 6, which one stands for 600? Now, this 6 stands for 6,000. Alright, so definitely it's not the first one. Now this 6 stands for just 6 ones, so it's not this either. This 6, you see, is the third digit from the right. This one stands for 600. And the last one, this 6 stands for 60. So answer is 3. Okay, now let's take a look at the next one. Which of this digit 5, what does this digit 5 stand for? Now, ones, the digit 2 stands for 2 ones, it's in the ones place. Then the digit 8 is in the tens place. It means that digit 8 is 0.8. That's not what we want. The next one, digit number 5. This one, 5. Now, 5 here is in the hundreds place, which means that is actually 0.05. Okay, let's go to the next one now. Let me clear this. Question 3, similar type of question. The value of the digit 4. Now, it's similar to stand for. So, what is the value? Which means, what is it worth? This 4 is like 4, you see 3, there's the 3 place values here. So this is like 4,000. So this digit 4 stands for 4,000. Next one, the value of the digit 2. So again, what does this digit 2 stand for? This one stands for 2,000. It stands for 2,000. Hence, answer for this is 3. And the answer for this is also 3. Question 5, we're talking about questions on multiples. Now, I like to think of multiples are like something like our times table, right? We want the fourth multiple of 7, the third multiple of 9, and they're supposed to sum them. Now, summing them means to add them together. So, let's talk about the multiple of 7. Multiple of 7, the fourth multiple of 7, this is the first, second, third. This is the fourth multiple of 7, it's like 4 times 7 is 28. Third multiple of 9 is like 3 times 9, 27. And we're supposed to sum them up, so adding them together gives us 55, and that is number 3. Next one, 42 is not a multiple of something. So what does it mean? Okay, think about your multiplication and can you multiply something to get that number? So for example, 7, I can multiply by 6 to get 42, or I can use 42 and divide that by 7 and I can get 6. If I can multiply by a number to get 42, then this is a multiple of 40. Then 42 is a multiple of 7. 7 times 6, so I get 42. And that's not what we want. I know 6 times 7 will give me 42. That's also not what I want. 3 times 14, I get 42. I do not want this number. Now 42 is not a multiple of 4. Because I use 4 times, if in my 4 times table, right, I can go to 40. After 40, I go to 44. But you see, 42 is not in the 4 times table. So 42 is not a multiple of 4. A different kind of question from the multiples question with factors questions. Now, when we talk about factors, what we mean is this. Factor of 18 is, what are the numbers that multiply together that can give me 18? I know 1 times 18 is 18, 2 times 9 is 18, 3 times 6 is 18, 6 times 3 is also 18, but since it's repeated, I do not rewrite them again. Likewise, multiples of 24, 1 times 24 is 24, 2 times 12 is 24, 3 times 8 is 24, 4 times 6 is 24, and usually I will go down in a systematic step-by-step manner, starting from 1, then I go on to 2, 3, 4, 5, 6, so on and so forth. Now they ask us for which of the following numbers here is a factor of both of these. So I look for a common number, and I see that the number 6, right, is present in both sets of my working. So therefore the answer is 6. Why is it not 12? 12 is here, but it's not a factor of 18. 9 is a factor of 18, but not a factor of 24. 7 is not a factor of either one of them. Okay? Next one, which of the following are common factors of 16 and 28? Now this, when we talk about common factors, it's like saying which of the factors appear in both of this set of numbers. So for 16, again, go on to 1 times 16 is 16, 2 times 8 is 16, 4 times 4 is 16. For 28, 1 times 28 is 28, 2 times 14 is 28, 4 times 7 is 28. And which of these are common factors? So I can see that 2 is present in both sets of working, 4 is present in both sets of working, therefore I see this as my answer. Now next one, similar type of question, which are the common factors of 36 and 24? So again, I have my working out for me, and I can show the working as below already. I work them out. So common will be looking for numbers that appear in both. So I see 2 and 3 here, I see 2 and 3 here, therefore 2 and 3 are common factors of 36 and 42. Now, of course, it goes without saying that to do this question well, you must be very good with your times table, right? To do questions on multiples and factors well, you must know your times table very well. If you do not, please practice them. Next one, question 10. Which of the following is a multiple of 7 and when it's divided by 3 gives a remainder of 2? So let's do a process of elimination first. Multiple of 7 means I need numbers that are in the 7 times table. 16 is not in the 7 times table, so cross it out. 65 is not in the 7 times table. I cross it out. I know because I'm familiar with my 7 times table. Then, which of these numbers left, which is 28 and 35, when divided by 3, will give a remainder of 2. So I just do my working. I have 28 divided by 3. 3 times 9, 27. 8 minus 7 is 1. I get a remainder of 1. And it's not remainder of 2. So I know therefore 28 is also wrong. But just to be very sure, my answer is 35. So I divide 35 by 3. I get a remainder 2. Alright, therefore the answer is number 3. Okay, now we move on to a different kind of question, and that's from your chapter 3 of your textbook. If you're not familiar, always can go back to your textbook or your workbook in your revision and practice again. Now, chapter 3 is on 4 operations of whole numbers. Now, operations refers to plus, minus, times, or divide. These are the 4 operations. Now, Susan bought 72 stamps. Jeanette bought 4 times as many. So be familiar how you draw your model. So if Susan has one part, which is 72, Jeanette has 4 times as many. So of course, I will shade Jeanette 4 times. 1, 2, 3, 4. Now, how many more stamps did Jeanette buy? When we talk about more, the idea of more is the part that is extra, right? This part is the more part. Not this part, because this part here, this part that I'm going to highlight in orange, this part is the same as the part above. So it's not more. The more part is this part here. So how many more stamps did Jeanette buy? Now based on the model, I can see that 72 is in each of the box here, right? 72. So therefore, the more than part will be 72 times 3. There are 3 72s. I multiply 2 times 3 is 6, 7 times 3 is 21. I get 216 more. Next one, let's go on to question 12. The total cost of a dining table and 8 chairs is 1,512. So we have one dining table and 6 chairs. The dining table costs 3 times as much as a chair. So one dining table costs 3 times as much as a chair. Now how many chairs are there? You saw earlier on that there are 6 chairs. So this will be 1 chair, 2 chairs, 3 chairs, 4 chairs, 5 chairs, 6 chairs. And altogether, all these things cost 1,512. So I can count here, right? How many equal parts do I see? 1, 2, 3, 4, 5, 6, 7, 8, 9. So all these 9 equal parts here is equivalent to 1,512. I divide by 9 and get 168. And that is the cost of each chair. Each chair means 1 chair. Now the working is shown below, how you do your division. Next one, question 13. What fraction of the shapes are triangles? So firstly, how many shapes are there altogether? You can count, right? There are 1, 2, 3, 4, 5. There are 10 shapes altogether. And how many are triangles? 1, 2, 3, 4. There are 4 triangles, and that's the fraction. And I see 4/10 here. So 4/10 is the answer. Next one, how many 1/5 are there in 3 holes? Now, in one hole, this is one hole. In one hole, you see that there are 5/5. How do I know there are 5/5? Because if I add up 5 1/5, if I add up 5 1/5, what will I get? Pardon my slow writing. Not easy to write with a mouse like this. Give me just a second more. Right. If I add up 5 1/5, 1, 2, 3, 4, 5, I will get 5/5, which is the same as 1 whole. That's what I mean. If there are 3 holes, if there are 5 1/5 in one hole, then 3 holes means 5 plus 5 plus 5. There will be 15 1/5. Okay? Or 5 times 3 is 15. And the answer is 4. Next one, question 15. Which of the following is not an equivalent fraction of 1/4? Always take notes of words like this because we are too trained to answer questions about we're too trained to find the correct answer and not finding what is not the correct answer. Now, equivalent fraction means, is this something I can simplify further? So like 2/8 I can simplify to 1/4. 3/12 I can simplify to 1/4. 6 out of 24 I can simplify to 1/4. This is the only number that I cannot simplify any further. It definitely cannot become 1/4. So therefore 5/16 is not an equivalent fraction of 1/4. And the answer is number 3. Which of the following is equals to 4 whole to 7? Now this is what we call a mixed number. A mixed number has a whole number and a fraction beside it. Now, so we can change it to an improper fraction. Improper fraction has a numerator that is bigger than the denominator. So how do we do it? We use 4 whole here multiplied by 7. I get 28. And I add to this 2. 28 plus 2, I get 30. So this is my improper fraction. And I do see it here. And therefore answer is number 3. Which of these is not in the simplest form? Simplest form means I can no longer simplify it any further. So for this fraction, I can still simplify it. I can divide by the numerator and the denominator by 4. I can get 2/3. All this rest of this fraction here, 3/4, 4/7, and 5/8, I can no longer simplify them. So of course, they are already in the simplest form. Answer is 4. Question 18. Arrange the following fractions from the smallest to the greatest. Now, you may have a more efficient or elegant way of doing it. This is how I would do it. Now, first and foremost, I will try to compare and see if the teacher is so nice to give me fractions where I have all the numerators the same. So let's recap. Let's do a quick revision here. For example, if I have all the same numerator, then it's very easy to tell which fraction is the greater fraction. Alright, if the numerator is the same, means they are all one part. One part of 8. If I cut one whole into 8 parts, this is 1/8. If I cut one whole into 6 parts, this is 1/6. Of course, 1/6 is larger than 1/7. 1/7 is larger than 1/8. So this is the smallest, this is the greatest. Now, I also know if the denominator is all the same. I'm just going to recap. This is not directly linked to this few fraction. For example, if the denominator is all the same, then when I look at the numerator, for example, if this is 1/4, 2/4, 3/4, if the denominator are all the same, then this will be the largest fraction. This is 3 pieces out of 4. This is the smallest one. If I cut a piece, one whole into 4 parts, this is just 1 part. Now, having revised that, let's take a look. Okay, I do not see any of these having the same numerator, so I cannot use this way of comparing them easily. None of the denominators are the same. I cannot use this way immediately. But what I can do is, I notice something. I notice these two numbers, I can change 4 into 8. Alright, why do I want to do so? Then it becomes this kind of fraction where I can compare easily. How do I change 4 into 8? I multiply by 2. So numerator I multiply by 2 and I'll have 6/8. Now that I have this, remember what we talked about here? Now we can see that of course 6/8 is larger than 5/8. Next, why I change to this? Do you see something? Do you see that now I have a 6/7 and a 6/8? We can compare this and see which one is larger. Remember, if the numerator are all the same, then we look at the denominator. So this would be larger than this. Alright, 6/7 is larger than 6/8. So the largest fraction should be 6/7. And the smallest one should be 5/8. Okay, so this is another way of doing this without, so ignore this working. This is faster. Then answer is 3. Okay, so far you hung in there with me for the past 18 questions. Well done. We have moved to, now we are at chapter 7. If you would like to take an eye break, you can take an eye break before you come back to this video. Welcome back. Now let's take a look at chapter 7 on angles. The figure below is not drawn to scale. ABCD is a rectangle. Find angle X. To solve such question, you must remember certain properties of different shape. For example, if this is a rectangle, it tells you that all the angles are at the corner are right angle. So you know this angle here is, this whole angle is 90 degrees. Now if one of this angle is 30 and the other angle there, alright, is actually 20, therefore the angle in between, very simple. You just use your 90 minus away 30 minus away 20, and you get the angle X, which is 40 degrees. Next one, chapter 8. You need to know the properties of lines when you talk about parallel or perpendicular. Now both start with the letter P. I can understand sometimes why that can be confusing. So how can you remember? I remember it this way. You see parallel have two L's here. L and L. Right? Parallel. Do these line meet? They never meet. No matter how I extend the line, they will never meet. So if I'm asked to talk about parallel lines, I'll look for lines that never meet. So they say that which of the lines is parallel to AB? This is AB. This line is called AB. So a parallel line must be this. See? It does not meet AB. And this is line that we call CE or EC. Same thing. Alright? That's why this is the answer. Next one, question 21. One of the lines here is parallel to AB. Again, the word parallel. Remember, parallel, you have your double L here. Parallel means lines that never meet. Where is AB? AB is this line. Therefore, CD must be the parallel line. You see, it looks like this. So either DC or CD there. This is the answer. Simple, right? So for some of the questions, you can solve it easily in seconds without working. Now, next one, which of the following has perpendicular lines? I don't see double L here. Therefore, perpendicular refers to lines that meet at a right angle. And the right angle is this. And right angle means 90 degrees. So, I see a right angle here. No right angle, no right angle, no right angle. So this is the only one with a right angle. Chapter 9. See, you're making very good progress. Express a fraction as a decimal. Now, how do you do this? You just divide it by, you see, 100, right? So therefore, you divide it by 100. That means you move the decimal to the left, starting from here. 1, 2. So this is where the new decimal place is. Add a 0 in front. And therefore, your answer is 0.38. Alright, 0.38. Now we go on to chapter 14. We're going to skip to chapter 14. Now, symmetry. Now, line of symmetry will cut a particular given shape or picture into two exact equal halves. And these exact equal halves look like mirror images of each other. So I've drawn this line for you to show you. This line cuts figure B into two equal halves. Likewise, for this line here, cuts figure D into two equal halves. This half that I'm shading is actually equals to this other half. Likewise, this half, alright, is equals to this half here. So for question 24, the answer is B and D. That's number 4. Okay, now we are done with paper 1, section A questions, those MCQ questions. We're going to go on to section B. Now, section B is not MCQ, so you have to do the working and show your working. Now, rounding off this number to the nearest 10. Now, rounding off understanding is something like this. Now, for example, you have a number line, and you have a number, let's say 9,500. Now, it's the nearest 10, right? So the digit 2 is in the 10th place. So I start with, this 2 stands for 20. So it's 9,520. The next 10 is, after 20, will be 30. So they're asking this number, 9,225. So that is the number here, 9,225. Which number is it nearer to? Which 10 is it nearer to? Is it nearer to 20 or 30? Of course, the teacher will have taught you your circle, your underline. If it's 5 or more, you add 1 and you get 30. Okay? And 9,530. This part is just to show the understanding of what does rounding off to the nearest number means. Try to find the nearest one. If it's 5, it's right in the middle, we always move to the right hand side to the larger number. Next one, write 18,049 in figures. So this is 18,000. Right, 1,000, you have 3 0, then 18 is just 18. 49 is just here. I just add them together. I have this. A common mistake will be missing out this 0. If you miss out the 0, it becomes 1849, and that will be wrong. What is the remainder when you divide 2069 by 7? For those who are not too familiar, you may want to draw lines to help yourself see. Alright, so you don't forget stuff when you do your division. Okay, so for example, there's nothing here, right? Okay, now I see the number 20. So I know my 7 times table. 2 times 7 is 14. Can I use 3? I can, but then it will be 21. 20 cannot minus 21, so I cannot write 3 here, right? 2 times 7 is 14. 20 minus 14 is 6. Then I bring 6 down, 66. 7 times 9 is 63. 39 here. 7 times 5 is 35. 4 here. Remainder is 4. Okay? Now, if you find this question difficult, it means your times table or your 7 times table is really bad. Please, you got to go and memorize the 7 times table. Or in the exam, you just keep doing your repeated addition first. Don't just give up. Just keep adding 7. 7 plus 14 is 21. Then you plus 7, you get 28. Then 28 plus 7, you get 35. What I'm doing here is to show you how you can build your own 7 times table without having to memorize it. It will be slower, much slower, and I don't advise doing this, but it's better than nothing. Alright, if you can't remember it in time, alright, at least you do this. And when do you stop? You stop when you get to the tens, which is 70 in this case here. So for 7 times table, you build up to 70. Why 70? You check. If after adding 7 many times, and the last part you don't get a 70, it means you have added added wrongly somewhere along the line. Okay, so how do we use this? For example, how do I know it's 2? Alright, 7 times 2 first, 1, 2, I get 14. How do I know this is 9? Simple. Hold on a moment, now let me just erase something off here. Okay, now how do I know this is 9? And how do I know I get 63? Well, you see, 1, 2, 3, 4, 5, 6, 7, 8, 9. See? I get my 63. And how do I know 35? 7 times what number get 35? I know it's 5 because you see 1, 2, 3, 4, 5. I get my 35. So don't give up. You can build your own timetable in the exam if you need to, if you really can't remember it for now. Okay? That's all I'm going to talk about this method, which is not a very good method, but it's better than nothing. Next one, question 28. Again, if you can't do this, means your 6 times table is no good. You got to build it up. Just divide and you get this answer. Again, very similar to the one before. The earlier one was 18,049. This is 18,064. Okay, write down this in figures. Figures means in a number. Add this together. You must remember to carry over, right? And this will be 4,821. These questions are very simple, so I'm just going to breeze through them. Same for this, you multiply by this. Now, here I will just spend a bit of time to explain why I have so many workings here. Actually, you don't need so many. For those who are very familiar, all you need to do to solve this is this. Alright, 112 multiplied by 31. So basically multiply by 1 first. 112 times 1 is 112. Then I'm going to multiply by 3. So 2 times 3 is 6. 1 times 3 is 3. 1 times 3 is 3. Remember this part, there's nothing. This part is supposed to be a 0. Then I add this together. I have my 3,472. Now, if you find this difficult, what you can try to see is to see 31 as 2 numbers. 30 plus 1. Then you multiply them separately. For example, 112, instead of multiply by 31, you multiply by 1. Then very simple, right? Anything times 1 is just a number. Next one, you multiply by the tens, which is 30 here. See? Now I multiply by 30. This 3 stands for 30. That's this working here. Again, it's quite simple. Then finally, remember, there's a plus. I need to add these two numbers together and I get this. Again, I do not recommend doing this because this require do a little bit more, write down a little bit more, a few more numbers, and spend a few more seconds. But if you really can't do it this way, then try to understand it this way. Okay, that's why in the second question here, 30C, I showed you how to do it the other way, right? The slightly longer way. You should think of 42 as 40 and 2. I'm sure all of you can multiply by a single digit and get 960. And you can multiply by a tens, right? Let's multiply 480 by 4, then add a 0 at the back. Then finally, you must remember to add them together. Of course, if you are great at multiplication of 2-digit numbers, you can just do this. And you still get the same answer. So the rest of this is the same thing. I give you many questions to practice. I'm not going to explore through every single one of them. But just take note that if you can't do this, try doing it this way. Alright, separate 34 into 30 and 4, multiply and then add them. Separate 57 into 50 and 7, multiply them, then add them together. Separate 11 into 10 and 1, multiply them and add them together. If you are in my group, remember, you got to show me the working that you have chosen. Either you have done this way or on the right hand side way. Next one, question 31. Tom has 85 cards. Jerry has 45 cards. How many cards must Tom give to Jerry so both have the same number of cards? Very simple. First step, let's find out. There are several ways of doing this. This is one way. I find out firstly what is this extra part. Alright. That will be 85 minus 45. This part is 40. If this part is 40, then he need to give away half, right? Half of it. He need to give away half of it. And bring this half down here to give to Jerry. So half means I divide by 2. I get 20. And that's the answer. Okay. Next one. Express 912 in simplest form. That means I just simplify it. I try to divide the numerator and the denominator by the same number. And I notice that 9 and 12 are all in the 3 times table. So I can do this. I divide by 3. I get 3. I divide by 12 by 3. I get 4. And I have 3 quarters. Next, changing this into an improper fraction. We did earlier on in one of the section A question. And the method is simply this side here, you multiply first. 3 multiplied by 5 is 15. 15 plus 4 is 19. And I keep it this way. That is called improper. The numerator is larger than the denominator. Okay, we are more than halfway through. Hang in there. Now, to subtract a fraction or to add a fraction, we must always change the denominator to be the same number. Now, this currently is different, right? It's 4. Let's change this 4 into 8. So it's the same as that. How do we change 4 to 8? I multiply by 2. I must not forget to multiply the numerator by 2 as well. So I have 2 8. So now this is a minus, correct? This is a minus. So what is 5 minus 2? That will be 3. How about the denominator? We keep the denominator the same. So the answer is 3 8. Next one, arrange from smallest to greatest. Remember I said earlier on, if the numerator are the same, alright, then we can compare these two. But heck, this one is not the same. So what else can we do? I can change all to 16, all the denominator to 16. So this is what I can do. I change all the denominator to 16. So in other words, I can change this to a 16. How? Times 2 times 2, I have 10. Now, what am I comparing? I'm comparing 5, 11, and 10. So the smallest number will be 5. So 5, 16 is here. The largest number is 11. So I put down 11, 16 here. And last part, be very careful, is this. I don't write 10, 16 because 10, 16 is not inside here. Instead, I write down the equivalent fraction of it, which is 5, 8. Right? So sometimes some of you can be careless, you did all this fantastic working, but instead of 5, 18, you write down 10 over 16, and then what a waste, right? And you don't get the mark. Next one, which of the following fractions are smaller than 12? Sorry, are smaller than half. So one easy way of doing this is to think about the size of the fraction. 2/3 is more than half. So it's definitely not smaller. Out. 3/6 is actually half. It's not smaller than half. Out. Now left with these two. Because half of 12 is 6. Half of 9 is 4.5. So which of these are smaller than half? So these two are smaller than half. As a mixed number, remember, is a whole number, and then beside it is a fraction. So you can do it two ways. First way is this way. I prefer this way because to me it's less work. This means 17 divided by 5. 17 divided by 5. 5 times 3, 15. 17 minus 5 is 2. This is my 3 whole. This is my leftover 2. And it was divided by 5. See? 5. Another way to understand this is I split my 17 over 5 into 5 plus 5 plus 5 plus 2. Alright, and these three things add together is actually 3 whole. This is 1 whole. This is another 1 whole. This is another 1 whole. And then beside it is my 2/5. Next one, similar kind of question, write as a mixed number. I'm not going to go through this. To subtract fraction, as I mentioned earlier on, fraction, you got to change all the denominator to be the same. I can change 5 to a 20. So, yeah, I multiply by 4. Numerator multiply by 4. I have 4 minus 3. I have 1. How about the denominator? We don't do anything to it. Let's keep it the same. So, it's 1 over 20. Now, this one is a slight twist on the earlier question. Instead of just fraction multiplied by subtract by fraction, here there's a whole number. I just need to change a whole number into a fraction. So what fraction do I change into? I look at what I'm changing the rest. Here I'm all changing to the denominator of 9, right? So my 1 whole will be 9 out of 9. So the working will be, what is 9 minus 1? That is 8. 8 minus 3, that gives me 5. Denominator, I keep it the same, 9. So answer is 5, 9. Alright, now for angles question. Name two angles that are greater than 90 degrees. So here, if I do this, I just use a ruler and I place it there. Or if you're good, you can eyeball it. So here, I know this angle is larger than 90. This one is very obviously larger than 90. So E and C are the two answers. What is the smallest angle? Again, you should use a projector and measure, or you can eyeball it. Projector is the best. So if you use a projector, you can find out this is actually the smallest angle. This one. Right? Next one. Use a projector and draw. Now, so what happened is you have to put your projector. I'm just going to just draw it. They give you the line AB. So you put your projector over this. Alright. Make sure the 0 is right. Make sure this part, I'm going to highlight this part. This dot here where the B is right smack in the middle. Alright. Where there's a circle, like a zoom in part. Then, since the line starts here, look for the part that says 0. There are two numbers, you see. There's 180 and there's 0 on both sides. This side there's also 0 and there's also 180. Alright, so you look at where the line is. The line is here. So we start from 0. I repeat, we start from 0. Right? If this is 0, you go up to here, this will be 90. But you don't want 90, right? You want 115. Then look for 115. And then you put a dot here with a pencil. Remove your protractor. Alright, remove your protractor. Like what I'm doing now. Then use a ruler. You have to use a ruler. Draw a straight line down all the way until it touches this dot here. Right? Now, this one again, if you put your protractor down, right, and you will start your 0 from this side. This is where the 0 is. We go up to the middle here. On top, this will be 90. Right? Check some more where this line cuts. And this one will cut it at 130. Next one. Now, again, what does rectangle mean? Rectangle means all the angles are at the sides are equal to 90. So this whole angle here is equals to 90. Let's say angle Y is 4 times angle X is 4 times angle Y. What does that mean? That means that if I were to draw a model, right? Or okay, let's keep it simple. Huh? So X is 4 times. So imagine I just draw one more line out. One more line. And one last line. What have I done is I've cut up angle X into 1 part, 2 parts, 3 parts, and 4 parts. And if I add to angle Y, this is angle Y, you see there are 5 equal parts here, right? 1, 2, 3, 4, and 5. And all these 5 equal parts are equal. So 90 divided by 5, I get 18. So each of this part is 18 degrees. So angle Y is 18 degrees. Question 46, we are almost finishing. Hanging there, please. If you're tired, let's take a break. Come back in 5-10 minutes time. Don't take more than a 10 minutes break. It's a rectangle, find angle FED. Now, there are 2 kinds of ways it asks you to look for angles. One is measure. If it asks you to measure, this word measure means you have to use your protractor, right? Right? You have to use a protractor. Or they ask you, but if they ask you to find the angle, find means you calculate. Find means you calculate. So you know this whole thing here is actually 90. They're asking you, what is the angle FDE? F is here, D is here, E is here. So this angle that is formed by these 3 points, this angle here that I'm shading, this is your angle you're supposed to find. You cannot use a protractor, you will not get the correct answer. Since you know this whole thing is 90, you take away 36, you take away 10, and you will get the answer 44 degrees. Now we're expressing decimals as fraction. Again, very straightforward. I see that there's 1 decimal place here. So this 1 decimal place means the fraction is upon 10. So I have 7/10. To subtract these 2 numbers, I must make sure this is 8.50. Don't forget this 0. 0 cannot minus 6 directly, you need to borrow. Okay? So I will not go into this in detail. You check my working and you try to get the answer. This is multiplication. When you multiply, you must always remember you have your decimal here, and don't forget the decimal in your answer. Question 50, also again multiply by a single digit, and the main thing is don't forget your decimal, right? Don't forget your decimal. Now next question, write 6/10 as a decimal. Now 6/10 means this, 6 out of 10. If you change it back to a decimal, it's divided by 10, right? So you move the decimal back one place, so it's actually 0.6. Now, of course, you don't need this kind of working to show. This is just for teaching purposes. That's why I'm showing you extra working. Now, 6/10 means this is 1/10, 2/10, the third 10, the fourth 10, the fifth 10, the sixth 10. Add together, you get this, and you can convert it to a decimal, right? Actually, for such question, if you are very good, you don't even need working to do this. Round off this to the nearest whole number. So whole number means I don't look at this, no need. This part here in front of the decimal is the whole number portion. So the number I must look at is the first digit here after the decimal. Is it 5 or more than 5? It is. So I can add 1 to 17. I get 18. Okay. Now, if your answer is 18, you are correct. But if you, itchy fingers, go and write down decimal and 0 and 0, then I'm sorry, then this is wrong. Because a whole number doesn't have decimals. No decimals, right? No tens place, hundreds place. Write the digit, the decimal represented by the number A, the letter A. So how do we do this? Well, my step that I will teach my student is instead of 0.6, you write 0.60. C as 60, C this as 70. If you can see as 60 to 70, let's count. 60, 61, 62, 63. Of course, it's 0.63, 0.64, 0.65, 0.66. And this answer, 0.66. How to double check? Keep counting. 0.67, 0.68, 0.69. After 69, 0.70. There, I checked. It is correct. Okay, now arrange these numbers from smallest to greatest. So I just arrange. And then I check from left to right. So 0, 0, 0, 0, all the same. Okay. Next, I'll check the next row. Oh, 5 is bigger. 0 is the smallest. So I know this must be the smallest. So it goes here. Next smallest must be this 0.4. It goes here. Okay. Now all that's left for me to compare is 0.503 and 0.53. Next row I compare. I see that here 3 is larger than 0. So therefore 0.503 is the next smallest, followed by this part 0. Sorry, this is my handwriting issue. This is not 0.53. It's actually 5.3. So you see, careless mistake. Even teachers can have careless mistake. It's actually 5.3. The answer here, 5.3. See, always need to check your work. Find the missing decimals in the number pattern below. So I notice that here, the numbers become smaller and smaller, right? By what? By 0.005. How do I know? I subtract by 4.010. If I subtract this, I will get 0.005. That's how I get this. So every single one I just subtract by 0.005. I get 4.005 here. I get 3.990 here. And that's how I get these two numbers. Next one, arrange numbers from small to the greatest. Now, sometimes they mix fractions and decimals together. Just change the fraction to a decimal. Alright, how do I change? I multiply by 2, I get 8. I multiply by 2, I get 10. I change my 4/5 into 8/10. Then 8/10, changing to a decimal is easy. Move decimal place to the front. So now it's 0.8. Now 0.8 is of course larger than 0.085. So this must be the smallest. 805 is larger than 800. Okay, this is how I see it. 0.8 is like 0.800. So this is the largest, so it goes this side. And 4/5 is my 0.8, and that is the middle size number. Now Janice has $80. She wants to buy a pair of shoes. Finishing, went down to the last few questions. She wants to buy a pair of shoes that cost $69.75 and a dress that costs $35.50. So if Janice wants to buy these two things, she needs to have this amount of money. Alright, she needs $105.25. But she only has $80. So how much money is she short of? Means she doesn't have enough. You use what she needs to pay, subtract away what she has, so she's short of $25.25. Okay. Next question. Jin Yang is heavier than Xijia by 11.8 kilogram. So where's the heavier than part? The heavier than is just this part. Total weight is 72.4. Total is 72.4. So how do we find Xijia's weight? Always need to find out equal parts. So I take away this part. Alright? Take away means I get 60.6. Why do I take away? Then I'm only left with these two equal parts, which I redraw for you below. So these two equal parts is now 60.6. One equal part, I just divide by 2, I get 30.3. So one equal part is like Xijia's part or Xilai's part, and that is 30.3. Next one, the figure is made of identical squares. 10 are shaded. Shade 2 more, so the AB is a line of symmetry. So if this is supposed to be the line of symmetry, AB, right? Then it must cut this figure into two equal parts. So let me just check. Alright, here I see a square here. Okay, on this side there's a square. Can. On the left hand side of this side there's a square here. Here no square, so I shade one square. I go down a bit. Touching this line there's a square. Good. There's a square. I forgot earlier part. Touching this square, there's another square. So touching this square, there's another square. Okay, correct so far? I'm going to check some more. Beside this square, there's a white triangle. White triangle. After white triangle, I see a square here. Okay, there's no square, so I shade this. Then I see one square touching this pink line, another square touching a pink line. That's fine. So now I've done my shade two more square. This one and this. Now, line of symmetry, complete the symmetric figure. So we are given AB as the line of symmetry. So if this is a line of symmetry, I draw in my shape to make sure it exactly cuts it into half. So you see whatever is on this side must be identical to what's on the other side of the line AB. See that? You may have to tilt your head to the right a bit to see this. Look like a cuttlefish. Sotong, right? Same thing here. Using AB as a line of symmetry, this is the line of symmetry down the middle. Now, you were given these lines on the right hand side. So I must draw something identical on the left hand side. So I can just see here 1, 2, 3. So I have 1, 2, 3. Here 1, 2, 3. I go down 1, 2, 3. Then go in 2 squares, go in 2 squares. Go down 2 squares and go down 2 squares. See? Exactly the same. And this is how I will tune my people to see this question. Right? And that's it. Good job hanging in there for the last 55 minutes. I wish you all the best in your end of year P4 Maths exam. All the best. I'll see you in the next video.